Hi mathematicians, let's get started with section 3.3. Corresponding parts of congruent figures are congruent. Our lesson objectives will be mathematicians will be able to apply the definition of congruence in terms of rigid transformations to identify congruent figures and their corresponding sides and angles. So that leads us to our essential question: what can you conclude about two figures that are congruent? So let's take a look at our first key point, identifying congruent figures. In order for us to answer this essential question, we need to know about congruent figures. What are congruent figures? They are figures that have the same size and shape. All right, so let's take a look at two properties that must be true for all congruent figures. All corresponding angles are same measure. All corresponding side lengths are equal. If both of these are true, then you have congruent figures. Here are some examples. Even the orientation is different, but they can still be congruent if both angles and sides are congruent and equal. Example of not congruent would be different size or different shapes. So let's recall. Note that you can identify congruent figures in the coordinate plane by identifying the rigid motion or composition of rigid motions that maps one of the figures onto the other. So let's recall, which of the transformations are rigid motions? Well, it's all three. Translations, reflections, and rotations all have rigid motion. In other words, after you complete these transformations, the size and shape are the same. So corresponding angles are congruent and corresponding lengths are equal. Okay, next let's take a look at explaining how to identify congruent figures under certain transformations. So we have our figures over here that we can use. So the first transformation we'll take a consideration of is translation. So if we observe square in PQR and how it maps or translates to ABCD, we can see that it moved to the right and up. So specifically, we can say that every XY coordinate maps onto a movement by a translation of 2 to the right. So that should actually be a plus, x plus 2, so x plus 2, and then up 6, so it should be a plus 6. So our mapping is x plus 2, comma, y plus 6. So this translation, square ABCD and square MPQR are congruent according to this translation, so it's a rigid motion. All right, next let's take a look at a reflection. So triangle KLM, so we can see KLM here, is reflecting onto EFG across this line, the x-axis. All right, and so we can say it's a mapping of every xy coordinate onto x, comma, opposite of y. So triangle EFG and triangle KLM are congruent. All right, next let's take a look at a rotation example. So triangle STU is rotated 180 about the origin, so we know it'll rotate up to this quadrant, and there it is mapping onto triangle HIJ. So XY maps onto opposite of x, comma, opposite of y. So triangle HIJ and triangle STU are congruent. So that leads us to key point number 2. The following true statement summarizes what is the main topic of today's lesson. We have corresponding parts of congruent figures are congruent, CPCFC. And it states if two figures are congruent, then corresponding sides are congruent and corresponding angles are congruent. All right, next let's take a look at the application of this definition of congruent parts. of congruent figures are congruent to this example number 1 where we have triangle ABC congruent to triangle DEF. And we're going to find the length from A to D. So that's going to be from A to B. That should say B. And then the measure of angle D. All right, so instead of D, let's fix that. We'll find from A to B. Okay. All right, so first we have to see the relationship. And so we can see that AB, A, and B are first two letters in the arrangement of the triangle congruence statement. So my congruent statement has A and B first, so that means it corresponds to D and E. So AB corresponds to DE. Therefore, these two segments are equal in length. So my setup would be, I start by saying AB equals DE. That's the geometric relationship. Then I substitute the algebra. And then my steps after this are all solving for x. So isolate the variable, subtract 3x, divide by 2, so x equals 4. Next, I will substitute that 4 into the expression that is the length from A to B, which is 3x plus 8. So 3 times 4 will be 12 plus 8, which is 20. So AB length is 20 inches. Next, let's take a look at measure of angle D. So we know that measure of angle A is going to be equal to the measure of angle D. So I can go to my congruent statement and find A in the first part. It's the first letter. So I go to the first letter of the next named triangle, which is D. So A and D correspond and therefore are equal in measure. So my setup is measure of angle A equals measure of angle D. Next, I substitute, so 5y plus 11 equals 6y plus 2, based on the givens in the picture. Then it's algebra from here, where I solve for the variable y, subtract 5y from both sides. Combine like terms, then I subtract 2 from both sides, resulting in y equaling 9. And then I substitute the 9 will substitute back into the equation for the measure of angle D. So 6 times 9 plus 2 results in an angle measure of 56 degrees. So we used our CPCFC property and definition to set up and solve for these two measurements. All right, so this leads us to our next explanation of applying the properties of congruence. Since rigid motions preserve length and angle measure, we can say that congruency is equal length, size, or measure. So when we're comparing segments, congruency versus equality, the notation is different. So please note the notation, very important. Having the bar with the congruent symbol indicates that an object has same size, same shape. If I want to talk about length, then I take away the bar and I'm just talking about the measurement, so the length being equal in measure. So this is object having size and shape. This has measurement. Same with angles. This is objects have congruency, so same size, same shape. But if I'm talking about measurement, then I have the little m with the angle symbol equals no congruency. So I will be looking for these correct notations. In your proofs, your implied statements for this definition are such that congruent segments imply equal length, and vice versa. So the double arrow means I can read it backwards, and it's also true. And then congruent angles implies equal measure angles, and vice versa. Equal measure angles imply congruent angles. These are considered biconditional statements. The converse is true, and the conditional is true. That leads us to our properties of congruence that we can use in our proofs. We've seen these properties before with equality. Now we see them with congruence. Your reflexive, so segment AB is congruent to segment AB. Symmetric, so if segment AB is congruent to CD, then CD is congruent to AD. That should say AB. I'm finding all kinds of errors. So we have, this should say AB, not AD. Sorry about that. All right, so next we have the transitive property, and that's if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. All right, finally, let's take a look at example number 2, where you have quadrilateral GHJK congruent to quadrilateral LMNP. So find the length from L to M and the measure of angle H. Based on example 1, see if you can try this one by yourself. So pause the video here, actually pause it, go ahead, and see about doing the work without watching first. Then unpause to check your answers. Did you pause? You didn't pause, did you? Go ahead and pause. All right, let's see if you got them right. So take a moment to pause here, look over the work, compare your work to my work, and see if you got the same answers. If not, do a quick error analysis, bring any clarifying questions tomorrow. Do a quick summary of this section based on your immediate understanding of this section, and then we'll clarify in class tomorrow. All right, bye-bye, mathematicians.